Alright, welcome to Transformations of f of x to g of x, Level 3. Now, in our very first example, we still want to describe the transformation of f of x to g of x. And notice f of x equals x squared is written in white, and I want to draw over my g of x using a different color because I want you to understand what is the difference from g of x to f of x. Well, in this case, we're simply multiplying the entire function f of x by 2. So g of x can actually be written as this, is equal to 2 parentheses, and whatever we see f of x described as, which is this, x squared, we're then going to put that entire function inside of parentheses. So f of x is x squared, and so I notice that here I have 2 times f of x. Well, that means we have 2 times x squared. Now, what is that actually going to look like? Well, we would have g of x is equal to 2 x squared. Now, much like in our other videos, you then want to take what g of x actually is, which is this, and you want to take what f of x was originally, which in this case was just x squared, and notice the only difference comes from their coefficients. So let me switch this red color, and we had a coefficient of 1, we have a coefficient of 2, and so whenever your initial term, your a value, is increased, you want to always divide the 2. So we'll take our new coefficient 2 divided by 1, and 2 divided by 1 is 2, and so we would simply say it was vertically stretched by 2. Now, that's not technically the correct way, so it would say vertically stretched by a factor of 2. I just didn't have the room to write it in, but you can write it yourself. Alright, let's move to our second example. Okay, here in example 2, we want to describe the transformation of f of x to g of x when we see that f of x is equal to 3 cube roots of x, or 3 cubic roots of x. My apologies. Now, g of x, let me go ahead and write in our blue, as I have been doing, is equal to negative 2 f of x, and I'm leaving f of x in white once again to illustrate, what parts of that function are g of x versus what parts are f of x. Now notice, we're multiplying the entire function of f of x by negative 2, which brings us to the question, what is f of x? And switching back to white, we know that our f of x is everything that we see right here, this 3 cubic roots of x. Now, switching back to my g of x color, we can write our final function of g of x, and we see right here we have negative 2 is right beside the parentheses. We know it's being multiplied, and so we multiply it by this coefficient right here. And what is negative 2 times 3? Well, that would be negative 6 cubic roots of x. Remember, this negative 2 cannot multiply to anything inside the square root, so this x remains unchanged. Now this is our actual function of g of x. This is our actual function of f of x. And notice we actually have 2 interesting changes here. One, we went from 3 to 6. Ask yourself, was that an increase or a decrease? Since it obviously increased from 3 to 6, we had a vertical stretch, by, and ask yourself, well, what is 6 divided by 3? Well, that's 2. So we had a vertical stretch by a factor of 2, and this is huge, we also went from a positive to a negative, which means it was reflected. So don't forget, whenever you switch signs from a positive to a negative or a negative to a positive, our graph is then being reflected. Go ahead and finish these notes, pause the video if you have to, and let's go ahead and move on to example number 3. Alright, so let's go on to example 3. We're still describing the transformation of f of x to g of x, and notice in this case we are still using multiplication. So I see that g of x is equal to 3 times the entirety of f of x. Now notice f of x is equal to negative 2 absolute value x plus 2 close absolute value plus 4. And so what would g of x look like? Well, g of x would look like this. It would equal this 3, which is being multiplied by the entirety of f of x. And what is f of x? Well, it is everything that you see here, everything that f of x equals. So you can write negative 2, absolute value, x, plus 2, close absolute value, plus 4. Now switching back to this blue, when we distribute, I find that this is where a lot of students have difficulty. So we can write this as g of x is equal to 3 times negative 2, the leading coefficient, which would then become negative 6, absolute value, x, and then you have a big question here. Should this 3 be distributed with the plus 2? And the answer is emphatically no. This is inside our absolute value bars. We cannot affect anything on the inside. So that x plus 2 will remain exactly the same. Closing the absolute value bars, however, notice this plus 4 is on the outside, and so therefore we do have to distribute to it, and 3 times 4 would of course be plus 12. Now this is my actual function, g of x. This is my actual function, f of x. And let me go ahead and switch to a red to highlight every single change. So, our first question, we went from a negative leading term to a negative leading term, and there was no change. So this was clearly not reflected. Let me say that one more time. Since it went from a negative to a negative, there was no change. It was not reflected. Now from here, we went from a 2 to a 6, and ask yourself, did that increase or decrease? Well, since it increased, we know that it was vertically stretched by a factor of, and once again ask yourself, what is 6 divided by 2? Well, that would be 3, comma, because notice x plus 2 didn't change. However, we went from a positive 4 to a positive 12, and let's see, from 4 to 12, did that increase or decrease? Well, it increased, and it actually increased by a distance of 8, so it says shifted up 8. And so now in this one, we inadvertently had two transformations. It was vertically stretched by a factor of 3, and it was shifted up 8 units.